What is IPsec? Internet Protocol Security. IPsec. IPsec, or so-called Internet Protocol Security, is a suite of protocols and algorithms for securing data transmitted over the Internet or any public network. The Internet Engineering Task Force, or IETF, developed the IPsec protocols in the mid-1990s to provide security at the IP layer through authentication and encryption of IP network packets. IPsec originally defined two protocols for securing IP packets: authentication header and encapsulating security payload. The former provides data integrity and anti-replay service, and the latter encrypts and authenticates data. The IPsec suite also includes Internet Key Exchange, which is used to generate shared security key to establish a security association. Tasks are needed for the encryption and decryption process to negotiate a security level between two entities. A spatial router or firewall that sits between two networks usually handles the SA negotiation process. What is IPsec used for? IPsec is used for protecting sensitive data such as financial transactions, medical records, and corporate communications as it's transmitted across the network. It also used to secure virtual private networks, where IPsec tunneling encrypts all data sent between two endpoints. IPsec can also encrypt application layer data and provide security for routers sending routing data across the public internet. IP, IPsec can also be used to provide authentication without encryption. For example, to authenticate that data originated from a known sender. Strength of IPsec. The IPsec, or Internet Protocol Security Protocol suite, is a set of network security protocols developed to ensure the confidentiality, integrity, and authentication of data traffics over TCP or IP network. IPsec protocol suite provides security to the network traffic by ensuring data confidentiality, data integrity, sender and recipient authentication, and replay protection. Some network threats, which are mitigated by using IPsec, are 1. Data corruption in traffic. 2. Data theft in traffic. 3. Password and account theft. And 4. Network-based attack. IPsec protocol suite is based on an Internet Engineering Task Force standards. Since IPsec is an IETF standard, we can have interoperability between different firewall, router, and operating system vendors. We can use IPsec to create VPN tunnels between devices made by different vendors like Cisco, Juniper, Microsoft, Red Hat, Checkpoints, Palo Alto, and etc. Primary goals of IPsec in 4 different ways. Confidentiality. The data in network traffic must be available only to the intended recipient. In other words, the data in network traffic must not be available to anyone else other than the intended recipient. IPsec provides data confidentiality to data by encrypting it during its journey. Integrity. The data in network traffic must not be altered while in network. In other words, the data which is received by the recipient must be exactly same as the data sent from the sender. IPsec provides data integrity by using hashing algorithms. Authentication. Sender and the recipient must prove their identity with each other. IPsec provides authentication services by using digital certificates or pre-shared keys. 4. Protection against replay attacks. Network replay attack, also called as man-in-the-middle attacks, allows an attacker to spy the network traffic between a sending device and a receiving device. Later, the replay attacker uses the information he gained illegally for fake authentication, fake authorization, or to duplicate a transaction. IPsec protects against replay attack by using sequence of numbers which are built into the IPsec packets by using the sequence numbers. IPsec can identify the packets which is already seen. Weakness of IPsec. Number 1. CPU overhead. All the data that is passing through the machine needs to be encrypted and decrypted constantly. Hence, IPsec requires high processing power from the CPU. This is especially disadvantageous if the size of the data packet is small. As IPsec generates large overheads, the performance of the network will be diminished. Compatibility. Some softwares developers do not stick to the procedures of IPsec. As a result, it can create compatibility issues with several softwares. Moreover, IPsec does not have any consistent standards for its own compatibility. 3. Algorithms. Security algorithms in IPsec are prone to crackings. If anyone happens to use those algorithms, their security is at greater level of risk. However, latest algorithms modeled today are known to prevent these vulnerabilities. 4. Access range. Since IPsec provides wide access range, it has higher chance of giving privilege to the other devices in the network. For an example, if any of the PCs happens to encounter malwares, all other computers in the corporate networks are affected. Therefore, unless there are special security measurements, the IPsec-based network is always vulnerable to cyber attacks. Number 5. Firewall restrictions. Sometimes, due to the restrictions imposed in the corporate firewall, users will not be able to access the internet, even if its own company's network. Therefore, only by contacting the network administrator, the users can access the respective network. What is the threats of IPsec? Researchers have demonstrated that the Internet Protocol IPsec is vulnerable to attacks. The Internet Key Exchange Protocols, or IKEV1, which is part of the protocol family, has vulnerabilities that enables potential attackers to interfere with the communication process and intercept specific information. Types of threats. Source routing. If available, the CS mechanism to abuse is IP source routing. Assume that the target host uses the reverse of the source route provided in a TCP open request for return traffic. Such behavior is utterly reasonable if the originator of the connection wishes to specify a particular path for some reason. Say, because of the automatic route is dead, replies may not reach the originator if a different path is followed. The attacker can then pick an any IP source address desired, including that of a trusted machine on the target's local network. Any facilities available to such machines become available to the attackers. Routing information protocol attacks is used to propagate routing information on local networks, especially broadcast media. Typically, the information received is unchecked. This allows an intruder to send bogus routing information to a target host and to each of the gateways along the way. To impersonate a particular host, the most likely attack of this sort would be to claim a route to a particular unused host rather than to a network. This would cause all packets destined for the host to be sent to the intruder's machine. Diverting packets for an entire network might be too negotiable or noticeable. Impersonating an idle workstation is comparative risk-free. Once this is done, protocols that rely on address-based authentication are effectively compromised. Exterior Gateway Protocol is intended for a communication between the core gateways and so-called exterior gateways. An exterior gateway, after going through a neighbor acquisition protocol, is periodically polled by the core. It responds with information about the networks it serves. This network must all be part of its autonomous system. Similarly, the gateway periodically requests routing information from the core gateway. Data is not normally sent except in response to a poll. Furthermore, since each poll carries a sequence number that must be echoed by the response, it is rather difficult for an intruder to inject a false route update. Exterior gateways are allowed to send exactly one spontaneous update between any two polls. These two must carry the sequence number of the last poll received. It is thus comparatively difficult to interfere in an ongoing EGP conversation. Opportunities of IPsec. When IPsec is implemented in a firewall or router, it provides a strong security whose application is to all traffic crossing this parameter. Traffic within a company or workgroup does not incur the overhead of security-related processing. IPsec's below transport layer, TCP, UDP, and is thus transparent to applications. There is no need to change software on a user or server's system when IPsec is implemented into firewall or router. Even if IPsec is implemented in end systems, upper layer softwares, including applications, is not affected. IPsec can be transparent to end users. There is no need to train users on security mechanisms. Issue keying material on a per user basis or revoking material when users leave the organization. IPsec can provide security for individual users if needed. This feature is useful for off-site workers and also for setting up a secure virtual subnetworks within an organization for sensitive applications. And that is all. Thank you.